Hi everybody, today we're looking at partial fractions, and the idea with a partial fraction is to write it as a sum of two or more rational functions where the denominator of each of those rational functions is a factor of the original denominator and where the numerator is a polynomial where the degree is at least, or the degree is less than the degree of the denominator. It could be at least a degree of 1 less, or it could be more than 1. Now remember that when we're talking about a degree, we're talking about the highest power of x in that polynomial. So the degree of a linear function is 1 because the highest power of x is 1. The degree of a quadratic is 2 because the highest power of x in a quadratic is 2. Okay, now it's really important that I show you an example because the example is the easiest way to see how the partial fractions works. So the first thing we do is we find the factors of the denominator. So x squared plus x take 2. I want to find the factors of that, and that's the linear factors of that. So I've just got to factorize this quadratic. So minus 2, positive 1, factors of minus 2 that add to positive 1 are positive 2 and minus 1. So there are my two factors. Okay, now when I split this up, I'm going to write it as some rational function with a denominator of x plus 2 and some rational function with a denominator of x take 1. It'll be the sum of those two. Now, if the degree is less than the degree in the denominator, the degree has to be less than a linear. Now, what's a lower power of x than 1? Well, it's x to the power of 0, which is just a constant. So I'm just going to say this is a and this is b. You can think about a as a times x to the power of 0, because this is 1. Or b is b times x to the power of 0, which is 1 as well. And so the degree of a constant is 0, which is less than 1. Okay, combine the partial fractions together by finding a common denominator. Well, our common denominator is going to be our original denominator, x squared plus x take 2. So it's a on x plus 2, and I've got to times this by x take 1 on x take 1. And b on x take 1, well, I'm going to have to times that by x plus 2 on x plus 2. Okay, so I'm looking to combine, so it's a times x, so it's ax take a, and the second one's going to be bx plus 2b. And that's going to be all over the multiplication of x take 1, x plus 2. So if I work that through, well, that's going to be ax plus bx take a plus 2b all over x squared plus x take 2. Now, I want to find a and b. So equate the general form for the numerator, which is ax plus bx take a plus 2b. And if I look back up there, it told us that originally it was 2x take 5. Now, what I'm going to do here is I'm going to equate the coefficient of x and the coefficient of the numbers without x, the constants. Now, if I take x out as a common factor, I'm going to be left with a plus b. So it's going to be a plus b times x, and it's going to be take a take 2b. Now notice the negative's out the front, so I've had to take a negative out of this term here, and the sign has become opposite. Now, if you want to justify why that is, if I'm multiplying this minus 1 by a, I'll get minus a, which works. If I multiply this minus 1 by minus 2b, I'll get plus 2b. And I took the negative out because I've got a negative here as well, so it's going to make it easier to compare. So a plus b equals 2, and a take 2b equals 5. Okay, so I've just got to solve these simultaneously. If I do, let's call this 1 and 2, if I do equation 1 take equation 2, I'll get a take a, which gives me 0. I'll get b take minus 2b, so I'll get b plus 2b, that'll be 3b. And if I do 2 take 5, that's minus 3. So b is equal to minus 1. And then a plus minus 1 equals 2. So a is equal to 2 plus 1, which tells me that a equals 3. So I've found a and b. Why do I want that? Well, remember I said a was the numerator over x plus 2. B was the numerator over x take 1. So finishing off, I can say that 2x take 5 on x squared plus x take 2 is equal to 3 on x. Now, I'm just got to remind myself. So the numerator over the denominator over a, or the a was over, was x plus 2, and b is minus 1, so let's put a minus in there and say that's 1 over x take 1. And that is a form that is expressing that rational function in partial fraction form. And I thought it would be useful just to link in the syllabus here, because it says the maximum of two distinct linear terms in the denominator, which is what we had in that example, with the degree of the numerator less than the degree of the denominator. So you're never going to get ones where the numerator is going to be more than the denominator. Okay, alright, so we will leave it there.